Okay, so now let's make number 2 happen. And in question number 2, oh boy, where's my 2? 2, there we go. We have this beautiful right triangle, thank you very much, D, F, E, and in this right triangle, the right angle's down at E, we know one side, the top side, and we know one other angle. We always know the right angle, but here we know one other one. Okay? And so, entonces, we need to do the other 3 pieces of information. We know that we have 3. We have one side, 2 angles, so we will be able to fill that in automatically. What we don't know is the other 2 sides and the other angle. That's what we have to find out still. So the first thing we're going to do is fill in what we do know. And what we do know so far is we know that DF is 18. Great. We know that angle E is 90, and we know that angle F is 51 degrees. Now the other 3 things we find out using the 4 different things we talked about over the past couple days. We could do the Pythagorean theorem if we had another side. We don't have enough information to Pythagorean theorem. We will probably have to use some sine, cosine, tangent, just like we've been doing. And then we will probably have to use that all triangles are 180. We won't have to use inverses because there's enough angles here to get by without that. But here we go. Let's talk about DE first. Just going in order. I'm going to put a little X there. Now look at the picture that you have now with the X there and the 18 and the 51. That looks like something you've done before. You have 2 sides and an angle. So we'll circle the angle that we know. Circle the angle you know. Now, what is side X from 51? Okay, it's across the triangle. It's on the opposite side. Side X is the opposite. OPP, right? And, of course, 18, the other side that we have information for is the hypotenuse across from the right angle. That's where the hypotenuse lives. You got to know that. I don't know how much of you have said that. Okay? Opposite hypotenuse. No, just kidding. That didn't come out right. Opposite hypotenuse. O and H. That tells us we're going to use sine. Sine is always of the angle, so we're going to do the sine of 51. And the sine of 51 equals the opposite side over the hypotenuse. Look at that. Not so bad. Sine of 51. Okay, turn this into a little proportion. Do the cross product. 18 times sine of 51 equals the other side. 1 times x, that's like our favorite thing to multiply. 1 times x is just x. So now we just go to our calculator and calculate. We have done the hard work. The easy work is punching buttons on our calculator. Okay, so when we punch this in on our calculator, it says 13.9886271. Yours may have more or less, but it should say something like that. For sides, now it says this on the board, for sides, you want to round to the hundredth. So x here is going to equal 13.99. So DE, I put the arrow there in red, so everything red lines up. DE is 13.99. Great, I'm not going to write that on the picture because I don't want my picture to get too crowded. I have to refer back to it every time, so if it gets crowded, it's going to throw us off a little bit. Now, we have 2 sides, right? We have 13.99, we have 18. We are able to use the Pythagorean theorem now to find EF. However, since we've already done that, let's do another sine, cosine, tangent one. I want to show you how you can do 2 at once. EF I'm going to call Y. How come? Well, X was already used. Let's call it Y. Now, assuming that we don't have X anymore, assuming that that's not there, now we still have 18 as one side, and we have Y as the other. Circle the angle 51. Y is now the adjacent side. And then 18 is still the hypotenuse. Nothing exciting happened. Oops, I'm moving stuff around. It's still the hypotenuse. Nothing has changed there. So adjacent and hypotenuse, well now we're going to use cosine. And the adjacent side is y over the hypotenuse 18. Put it over 1, make a cool little proportion. Do the cross product, 18 times the cosine of 51 equals y. And then go to your calculator. 18 times cosine 51. Y equals 2 decimal places, 11.33. I can guarantee you that if you do the Pythagorean theorem perfectly, you will get that answer. So if you're a Pythagorean theorem person, that's awesome. That's another great way to do it. Okay? Saving the best part for last, the easiest part, my most favorite part. Let's find angle D. In angle D, you could set it up and set up sine, cosine, tangent, use the inverse. That sounds awful. Let's do it an easier way. Angle D, well, there are 180 degrees in a triangle. I'm living over here in blue. I have a 90-degree angle. I better subtract that off. I can't. It's already used up at letter E. And then I have a 51-degree angle at letter F. Great, we get that calculator or calculating. 180, take away 90, take away 51. Our angle has 39 degrees that it can be. It is 39-degree angle at angle D. Okay, so different processes to figure this one out. You can pick some different options here. Now, we wouldn't be able to do the Pythagorean theorem right away. We pretty much have to start with the sine thing. But after that, you kind of have some options. You will use this style. This problem is very similar to question 5, 6, 7, 9. Hold up. 5, 6, 7, 9. Yeah, 5, 6, 7, and 9. So this will be 5, 6, 7, and 9. So if you are stuck on those, go back and think about what we did here. Okay? Refer back. Look at the different options. If you wrote them in color, great.